Okay, 6.4, law of sines. Okay, we already saw in the activity what the law of sines are, but let's just recap and make sure everybody understands. So there are three angles and three sides to every triangle, and if you take sine of that angle and divide it by the side opposite of it, then you have a proportion. And if you do that for all three sets, you have equal proportions. We're not going to use all three in any one problem. We're just going to use two, usually a piece of information that we know and a piece of information that we're trying to find. Let's talk about the types of problems where law of sines is useful. It's useful in a problem like this, where you're given an angle and then the side included. This is an ASA triangle. This means that there is only one triangle that fits this information. That means all the other things are set, that I can find them. Okay, let's think about what if this had been AAS. Let's think, instead of angle B, what if you had been given angle C? Would that really change the triangle? It really wouldn't change the triangle. You know here what this angle has to be. These three things have to add up to 180. So if I add 75 and 60 and subtract that from 180, I get 45 degrees. And again, this triangle is not drawn to scale. None of these are, so don't ever assume that. But if I had been given angle C as 45 and had to find angle B, I would have the same result. So for both of these are perfect law of sines problems, and the challenge here is not to find the missing angle. That should be the easy part. The challenge here is to find the missing side. Okay, so let's go ahead and use law of sines to find this missing side. So first off, you want to start with something that you know. So I know that sine of C is I know that C is 45 degrees. So sine of 45 degrees, and I know that side C is 340. So that proportion right there is going to be equal to, now when you set up the other side, I'm not going to write sine of 75 because I'm not trying to find side A yet. That could be my next step, but for right now I'm trying to find B. So I want to set this up as sine of 60. Now if you notice on this one, both of these angles are something that you could solve without a calculator, but we're not going to make you do that. You're just going to do this using the calculator like you did yesterday's lesson. So we're going to find this by multiplying. So B times sine of 45 degrees is equal to 340 times sine of 60 degrees, and then you're going to divide by sine of 45. Okay, so let's do this in our calculator. Again, just like yesterday, make sure your calculator is in degrees mode. So I gotta wake my calculator up. Here we go. Okay, so we've got 340 sine of 60. And then I'm going to divide by sine of 45. Okay, and I get 416.413. That's your answer. Now, how could you find the other side? How could you find A? Okay, I'm not going to actually do this in this lesson. You could, now you have enough information to use law of cosines if you really like law of cosines. Or you could use law of sines again. You have an option here, but you know how to find A. Okay, I want to get to the part of this lesson that's a little bit more interesting. So we've been talking about triangle postulates. So I want you to write this down. A unique triangle, meaning there's only one with the information that's given, is formed by ASA or AAS, which we said are basically the same thing. And this is where you're going to want to use law of sines to find those missing sides. All right, yesterday we had SAS and SSS, which are two different, but for both of these you could use law of cosines. In the SSS case, you would use it to find an angle, and in the SAS, you would still use law of cosines to find the missing angle, and then you could use it again to find the missing side. All right. Now there's one other thing that you talked about in geometry that we haven't yet talked about, and this is the SSA or ASS. If you remember, that's probably how you remembered that it wasn't a triangle postulate. The difference between SSA and SAS is where the angle is. If the angle is included between the two sides that you know, you're okay. That's a unique triangle. You know that triangle. If that angle, though, is not attached in between the two sides, but apart from it, this is called the ambiguous case. And think about this word ambiguous, what it means if you were to have just used it in everyday language. It would mean unclear. you're not sure exactly what it means. It could mean this or it could mean that, and you need more information. So the main thing we need to recognize here is that there could be two solutions. So let me explain to you using trig why there's two solutions. So for looking at problem 2, we can see that this is an SSA because I have a side, and then the angle is not included between the two sides. It's apart from it. Okay? What I want to do is I want to kind of show you why this could mean that there's two triangles. So let's just forget about this one for just a minute, and let me draw you what I mean. So let's say this side, I have no idea how long it is, but I know what this angle should be, and I know that this side has a definite length. Okay, let me actually switch around colors here. So I have a side that's set, and I have an angle that's set. This side up here is not set. Now, if I have a third side, excuse me, that's over here, if it's, you know, it could, if let's say it's set length like this. Okay, well, it also could have gone out like this. These two segments are about the same length. Those are two different triangles it could be making. All right, apart from that, the two solution thing, it could be that there is exactly one solution. That could be as well, and that could be a 90-degree triangle, or if this third side was just too long, if it was longer than this base side here, that could mean a one solution. Or let's say your third side here is just too short. That would actually mean a no solution. So I just reviewed a lot of geometry there. Feel free to bring your questions to class over that. But let me show you why for trig that there could be more than one solution. Okay, what I'm about to do is to show you what happens if you use law of sines on this problem. You don't have to write this down because I'm going to end up erasing this anyway. If you use law of sines here, what ends up happening, let's say that we're setting up law of sines and I have sine of 29 divided by 15, and I'm wanting to find, we'll just say side B. I'm sorry, we're wanting to find angle A or B. So let's just go ahead and write angle B. Let's do angle A. Sorry. So sine of A then would be over 26. And when you cross multiply and you solve for angle A, I'm not going to go through all the steps here, so I think you got them. You get 57.176 degrees. And that is one possibility for angle A. However, you have another possibility for angle A. I want you to think back to the last unit and several units. Whenever you're doing, let me show you, I am going to show you how this happened on the calculator because this is important and I don't want to skip over this. Okay, so we did 26 sine of 29 and we divided by 15, and then we got this 0.84, and now we're taking arc sine of this right here. Okay, and I get 57.176 degrees, okay, which is what I showed you here. Is there another angle that when I take sine, I get the same ratio of 0.84? Yeah, there is, and it's in a different quadrant. Okay, think back. This is 57 degrees right here. It's in quadrant 1. It's giving me a positive ratio of 0.84, positive 0.84. Where else is sine positive? In quadrant 2. This goes back to general solutions. And if you do 180 minus 57.176, you get 122.824. And so not only at this point do I have two possibilities for angle A, that's going to mean that I have two possibilities for angle B and then two possibilities for side C. Now you can actually continue this problem this way, and I have actually taught this way before. It's not that hard, but it's very tedious, lots of chances to make a mistake. So if you want to pause this and try to finish finding adding them up, subtracting from 180 to find b, and then you can either use law of sines or cosines to find the missing side. Then you can see if we get the same answer. I'm going to show you a different way, though, because it just gets very tedious having two lines of thinking going on. Okay, what I'm going to show you instead is what happens. One quick thing before I move on. It is possible that for either one of these, or for both, that you would hit a dead end, meaning that you would start to try to take arc sine of a number that's greater than 1. That would be a dead end. Or if you end up getting where your three angles are larger than 180, that would also be a dead end. So this is why the key word here is there could be two solutions. And in this particular problem, there is going to be two solutions. There also could be only one, like how we saw with the triangle, or there could be none if that third side was just too short. And so I'm going to simplify this process down, though. Okay, so I'm going to actually erase all this. If you want to go back and listen, you're more than welcome to pause or rewind the video. All right, so for problems like this, we're actually going to use law of cosines. All right, and let me show you what happens when we use law of cosines. Okay, when you're using law of cosines, you have to still kind of think about the side and the angle that you know. And so when we set this up, we're going to have 15 squared is equal to, now I don't know side B, so I'm going to have to just write it, side B squared plus 26 squared, and then I go minus 2 times B times 26, and remember you were using cosine, so this is cosine of 29 degrees. Now this isn't as bad as the first problem where law of cosines was useless, but this is pretty bad, meaning that if I'm going to work this by hand, I'm going to have to solve a quadratic by hand. Well, good news for you, you're not going to have to work it by hand. We're going to solve this on the calculator by graphing. One thing I want you to do, though, is make sure that this side is equal to 0. It's just going to make it that much easier to solve. Okay, so I'm subtracting. I'm going to subtract 15 squared here at the very end. Okay, and let's go to our calculator, and I've already said the keyword here, quadratic, which should be saying, yeah, there might be two solutions to a quadratic. There might be one, there might be none. So let's plug all this in. Okay, so what we're going to plug in is we're going to plug in x squared plus 26 squared minus 2x times 26 cosine of 29 degrees, and then close those parentheses behind that cosine, minus 15 squared. You've got to be really careful with your parentheses here. Now I'm looking for the roots, so I'm going to plug in 0 because that's what the other side was, and I'm looking for where these two curves, one's a curve, one's a line, but where they intersect. That's going to give me my solutions. And you may remember some of these techniques from pre-AP Algebra 2. If you don't, then just pay attention and you'll get them here. Now, my x value here is representing B. Now, of the two sides I see, 15 and 26, they're both pretty big sides. So when I go into my window, well, let's just hit zoom 6 and see what happens. This is not probably going to be a good idea, but let me just show you just to prove it. Okay, so I'm not seeing hardly anything. Okay, remember though that I'm not looking for a negative x, so you might as well change that to 0. And of the two sides that I know, one of them is already 26. So I'm going to go ahead and set x max to be 50 just to make sure that I can see. All right, you can change the scale if you want. It's not a big deal. And as far as y min and y max, you're just wanting to make sure that you can see the x-axis, so they're fine the way they are. Okay, so I could possibly see up to 2 intersection points, and I do. Okay, now not all parabolas have 2 roots. This one does. There are 2 solutions. So I'm going to hit second trace 5 for intersection, and I'm going to go ahead and narrow, well, let's just press enter. It's going to find the closest one, and then we'll find the other one. So one of my answers here is 14.609, and remember this is for side B. All right, let's do this again for the other one. Second trace 5. Make sure you're all the way where you're closer to the second one than you are the first. And what I'm doing is I'm looking at that y value, looking for it to come up, because your calculator will just keep finding the same intersection. Okay, and there's my other answer. Now, if there had not been 2 intersections, then I would only write down the one that I could find. And that means that if I had continued with law of sines, which was a very tedious process, I would have hit a dead end. In this case, it would have worked out. Okay, this is a much more efficient, quicker process. So here are my 2 values for B. These are actually 2 different triangles. Now, if you wanted to find angle A and angle B at this point, then you could. You could use law of cosines. You know, you have all 3 sides now. So I would encourage you to use law of cosines at that point. Just be aware that if you use law of sines to find angles, especially in this type of case, then you could be not realizing that there's 2 solutions when there are. And this is why I would encourage you to use law of cosines in this problem. Okay, let's look at number 3. So again, I've already written this down here. This is an SSA problem, SSA. All right, now if you use law of sines on this, you could be missing out on a solution. So I'm going to go ahead and just go straight away and use law of cosines on this problem. Now, ultimately, it's when you have 3 pieces of information, finding that 4th piece of information is usually the harder part. It's usually downhill after that. Okay, so if I'm wanting to find, the missing side here, let's say this was the problem, let's use law of cosines. Now, I still need to start out with this, meaning I still need to make this 10 squared equals, because I know 45. I don't know angle C or angle B. So 10 squared is going to equal 7 squared plus C squared minus 2 times 7 times C times cosine of 45 degrees. And when I use this in my calculator, I'm going to go ahead and subtract 10 squared so that it's easier if you're just finding the roots than if you are trying to find the intersection with 10 squared, which would be 100. Okay, so let's go into our calculator and let's plug this in. So that would be 7 squared plus x squared minus 2. I'm going to go ahead and x times 7, and I'm just kind of modifying this to how I need it. So that 29 needs to be 45 in this problem, and then this is minus 10 squared. Okay, in this particular problem, my 2 sides are 7 and 10, so maybe this doesn't need to be 50, maybe 20 is enough. Okay? And if I press graph, I can see one intersection. Now there actually is another intersection, and I'm going to go ahead and show it to you on this one. I'm going to change my window so that I can see it's a negative intersection, but I don't care about this negative intersection because it will not make sense if I have a negative value for a side of a triangle. So this is why when you set your window, just setting this to 0 will totally solve that problem for you. You won't even be confused by it. You do need to be aware that your x max is enough so that if there are 2 positive solutions that you are seeing them. But this is not something that you can just memorize how to do. This is just something that you're going to have to use your brain and think about. Okay, so here my C value is 13.639. And then from here, I would say go ahead and use law of cosines to find the missing angles B or C. Okay, let's do one more example. Okay, so here we have 2 sides and an angle, and this is an SSA. And if you're trying to find the missing side, then you would not want to use law of sines in this because you could be missing out on multiple solutions. We don't really have any idea right now. for sure what this triangle should look like. Now, if you're really good at geometry and you remember a lot of geometry, you're probably making some connections between how these triangles look and the outcomes, and that's good. Most of you're having to brush off a lot of your geometry just to keep up with this lesson. And so if you have a connection and you want to talk about it in class, I think that would be a good idea. So bring those questions or things that you thought about that may streamline this process. Bring those things to class. Okay. Again, law of cosines. To find this missing side, I don't want to use law of sines. So then I have 70 squared is equal to 122 squared plus c squared minus 2 times 122 times c times cosine of 42 degrees. And again, if you just subtract 70 squared and set that equal to 0, it'll make it much easier to find c. Okay, so let's plug this into our calculator. I'm going to actually clear this out because it seems like it's going to be pretty different. So we have 122 squared plus x squared minus 2 times 122 times x times cosine of 42 degrees, and then minus 70 squared. Now in terms of your window, the two sides are 122 and 70, so my third side could possibly be much higher than that even. So I'm going to go ahead and set this at 200 and we'll just see if this is enough. Okay, at this point I'm not seeing anything. Let's go to the table though, because it could be that my x value is just not enough, or it could be that it's not intersecting the axis at all. So if you look right here, at 0 I'm at 99.84, and then it just seems like it's just going to keep going up and up and up, or it seems like it's going down. Sorry, I have to keep ending that. It's going to go down. Is it going to go down enough? And I'm just trying to give you lots of ways to check this. Okay, let's keep going down. Guess I could have changed my table. Is it going to, what I'm looking for is y1 going to hit the x-axis? And probably a much more efficient way to do this would have been to change my table to go by tens or something. But I can see now that I'm already going back up. So there was a peak, it just didn't, or there was a low point. And what I'm going to do is I'm going to move this up to, say, 3,000. So we can see it, just to kind of be sure. So it did go down. It just didn't hit the x-axis. Okay, this is one scenario where you might have a no solution. Another scenario would be where the two intersections are both negative. Okay, so as weird as it seems for this type of problem, this is no solution. This triangle is not possible. This is not a triangle. It's not that there's two triangles. It's just that this right here, the information that I've given you, is not possible. It's geometry speaking, it's probably because 122 is so much higher than 70, then that would mean angle B would have to be so much higher than 42 degrees, and that would create a scenario where I already have over 180 degrees. If you think about the proportion for law of sines, or the fact that in geometry, angles, B would have to be bigger than A because of the side opposite. So there's a lot of reasons why that's not a triangle. The nice thing about that case is you don't really have to do any more work. Okay, so I realized this lesson was on law of sines, and I really only did one law of sines example. It's, though, the easiest one to use. The only time you're going to use it, though, is when you have ASA or AAS and when you're trying to find a side. Other than that, you're going to use law of cosines. Here, you wouldn't have to use either to find the missing angle. That's the easy part. And so law of sines is something that you really only use every now and then. This is the reason why we taught the second, is because for most of the time, it's much easier to use law of cosines. So like on any of these problems, we could have pushed through with law of sines, but we'd have had multiple scenarios, dead ends. It's just much more efficient to use law of cosines. Okay, bring your questions to class.